Hey guys, so I usually don't do too many videos like this, but I had a student of mine give me this question that he got in one of his assessments. And I thought it was a really good question to draw together everything we've learnt about indices. So, if any of this is new to you, I would encourage you to watch my older videos on indices and how we kind of come up with these like little laws that I've put in the bottom corner sort of for reference with this question. But I thought that it would be good to expose you all to what you may expect in like an end of the exam type of question, like a really abstract indice question that draws all of our knowledge together. So we have this question here, and this asks us that, or this tells us, given that 5 to the power of y equals 10, evaluate 125 to the power of y minus 1. Now, what the hell is going on here, right? Some of you, if you've done indices and you're quite comfortable with sort of regular questions of this form, that's good. But even my student looked at this and was completely stumped. Now, when we approach questions like this, we want to just, when we have something totally abstract, we just want to find a link between this and this. So we want to kind of write down what we know. Well, I've already given us a little reference here, which is our index laws. But what I want to do is I have some known. I have this 5 to the power of y, sorry about that, equals something. And we also have this thing here. Now we have a y in the power, but we don't have just a base of 5. But what is so significant about 125 here? How can we make a link between this number and this number? Well, 5 to the power of 3 is 125. So 125 can be composed of 5 times 5 times 5. 5 times 5 gives us 25, and 5 lots of 25 gives us 125. So, with just this initial link, opens the doors wide up for us in terms of answering this question. So, let's write our term here with a base of 5. And that will allow us to sort of start making a link between this thing here. Now, therefore, I can write 125 to the power of y minus 1. I can write that as, well, 5 cubed to the power of y minus 1. That's perfectly valid. All I've just done is write this number differently. But these two statements, these two terms left and right, are still equal because 5 cubed equals to 125. Now, what does this allow us to do? Well, now we have a 5 and we have a y as well. So we can kind of start chipping away at getting something in this form here because we know a piece of information that we're given from the question. Now, here we have a power of a power. Now, what can we do there? Well, we can consult our friend here in our index laws, which tells us that when we have a power of a power, that's the same as keeping the same base and just multiplying these powers together. So I can expand this thing up here. Well, I can say this is like saying 5 to the power of 3 multiplied by this entire term. 5 cubed multiplied by y minus 1. Now, we're getting closer. You can see we're getting a little bit warmer here. But what I'll do now is I will expand these brackets here. And let's see what that gives us. Sorry, guys. I have a very squeaky chair, so sorry if that's a bit annoying. But I have 5 to the power of this expanded. Well, our term on the outside is going to interact with each of these terms. So we're going to get 3 multiplied by y, which gives us 3y. And we will subtract 3 from there. Now, some of you may argue, well, we're still at a little bit of a standstill here because I have like a y here. That's pretty good. I've got a y and that's kind of some power of 5. But this thing here is problematic. But we can make a link. We can make another link. These abstract questions are all about just using what we know, but using it in a more abstract way. But we can say that, well, this is the difference of 2 powers, but where have we seen that? Well, we've also seen that here in our index laws. So we can write our 5 to the power of 3y minus 3. We can write that as, let's get a little bit closer. We can write that as 5 to the power of 3y divided by 5 cubed. And we can say that because all we've done from getting here to here is just going from here back here in our index laws. We have a difference of powers, so we can say that that's the same as one of these divided by the other. So that works. Now, this is handy because we have 5 cubed, and we know what that is. We have 5 to the power of 3y divided by 125. So we're kind of on the right track. But we still need this here. How do we do that with what we have here? Well, this 3y just means 3 multiplied by y. And that is this relationship here. So could we, in theory, just write, well, let me actually make a note of this. We can decompose this number here, because this is a product of 2 powers, we can say that this is some power to the power of another one of these. So this is like saying either 5 cubed to the power of y, that would give us 5 to the power of 3y, or, well, what's the other case? 5y all cubed. And we can do that because this does not violate our index law here. This is essentially by definition what we can do. We can break up this product of powers into 2 cases. Now, which one's going to help us here? Well, going back to our question, we have 5 to the power of y, and we're given that equals 10 here. So this bad boy over here will be very useful to us because, check this out, we can write this as 5 to the power of y cubed divided by 125. But we're given in the question, but 5 to the power of y equals 10. We're just given that in our question. We're told, given that 5 to the power of y equals 10, evaluate this thing. Well, we've simplified this thing Now we just have to link back to this relationship that we've done. So inside these brackets, I can sub in my 10 because 5 to the power of y equals 10. We've been told that. So we can say this is like saying 10 cubed divided by 125, which is like saying 1,000. 10 to the power of 3 is 1,000 divided by 125. And our answer is 8. That's pretty incredible, right? Because we've essentially used everything we know about index laws to get from here in the question all the way down to the number 8. That's pretty cool. Now in doing that, we've used 2 out of 3 of our index laws. We didn't have to use our first one here, but still use 2 out of 3. So this question required us to use a lot of what we know, but just in a really abstract way that may not be immediately obvious. But the most important thing is making this link here and kind of joining with this one. By identifying that 125 can just be expressed as 5 cubed, we have something in the form of a base of 5, which we can use. And the rest is really just mathematical manipulation. Now, this is just a really good question that I found to test what we know about indices, to draw together everything we know, but in a really abstract way. And this is your kind of typical end of the exam question here. This is that kind of discriminating question where your test creator says, well, I know you know the index laws. Let's see you use them in a not so straightforward way. I hope this helped, guys, and I hope it gave you an idea of what to look for when approaching these types of trickier questions. I'll see you next time.